I don't do a good job of that. So if you're like, Donahue, camera, might have some candy in it for you. But, so we have to set up our two equations here. So remember, because of, we talked about this yesterday, so what's underneath the absolute value could either be 9 or negative 9, because both of those would give us the same outcome after taking the absolute value. So we set up the two equations exactly the same except for what they equal, so either 9 or negative 9. So then we get to solve each of these. So we end up with x is 7 as one of our answers. And then also negative 2. So there's our two answers in that problem. What's different about our second example here? What do we have to remember to do first? We'll do first. Before we set up our two equations, we have to do something first. Yeah? Yeah, we have to get the absolute value alone. So we're going to isolate that absolute value. So I'm going to move this 6 over to begin with. So it's a positive 6, so I'm going to subtract 6 over. And you're actually going to maybe like this because you do 6 minus 6. When I go to set up two equations now, what happens? Yeah. There's only one equation. You can't do plus or minus 0. You only have to set up the one equation. There's only actually one answer that works for this problem because we want it to end up being 0. So when I go to set up two equations, it doesn't really make sense. So I just get x minus 5 equals 0. So we find out x is going to be 5 when I move that 5 over. So 5 is the only answer that would work in this problem. If you does anyone get a different answer other than 5? I'm trying to think of what the other answer would be. I believe it would be like a negative 7 or something if you got a different answer. So if you did try to set up two equations the way it was, and you got like negative 7 as your answer, I just want to show you guys, you can always check that to see if that works. If I do negative 7 minus 5, that's a negative 12, but I have to take the absolute value of that, which is 12. And 6 and 12 is obviously not going to equal 6. So if you're ever unsure, you can always set up, or always check your work. So we do only get one answer in this case because it needs to equal 0. Okay? So we're going to talk about inequalities today, and absolute value inequalities. So we're going to kind of combine the last few sections together. Just a heads up, this is actually our last section of new notes before we get ready for a test. My plan is to test with you guys on Monday. So do a couple days of review. Yeah. So we'll plan on a Monday test. I don't love Monday tests, but at the same time, I'd rather do 2 days of review than do just one day and try to squeeze in a test on a Friday. So we'll do a Monday test, do a couple days of review coming up here. So we're going to talk about kind of combining these two ideas today. So solving absolute value inequalities. So there's a couple of things to remember with absolute value and inequalities. So the name itself hopefully reminds you guys that there's a couple of things to remember. So first of all, the fact that we're going back to inequalities, this is pre-spring break, and I'm assuming that during spring break you didn't hang out with your friends and let's talk inequalities. I'm assuming. Well, right. I mean, unless you're like one of the cool kids, so I understand. But we have to remember that there's things about inequalities that made them a little bit more difficult. So just to make sure I include all my remember points, I'm going to grab my notes from. So think about what you guys know about inequalities and also absolute value. inequalities, the thing we want to remember, so the big things to remember with inequalities is when we multiply or divide by an inequality, we have to flip it, if you guys recall. So this is something we learned before break. We have to flip the inequality if we multiply or divide by a negative. So that was one thing we had learned about inequalities. Another thing to remember about inequalities is the open versus closed circle. And I kind of make like this little goofy face to help you remember that. So open circle doesn't have that equal to line, but if it has the equal to line, then we fill in the circle. So these are things to remember with inequalities. Then we also learned some things about absolute value. So absolute value we just learned yesterday is that we have to set up the two equations. We have to isolate the absolute value first. So the things to remember with absolute value. So you want to remember to isolate the absolute value first. And then once we do that, that's when we set up the two equations. So we're going to set up the positive version and the negative version. So basically we're going to take these two ideas and put them together today. So that's where we will need to, or you will need to, and these are going to be our steps for today. So we're going to add, like basically put those two ideas together. So looking at this inequality and its absolute value, we're going to put both of these ideas together. So the first step is we're going to isolate the absolute value. So you still need to do that. Obviously in step one, or in this first example, the absolute value is already isolated for you. Then we're going to set up our two inequalities, both a positive and a negative, but there's going to be a special trick with the negative, because it kind of comes from this flipping. So we're going to set up two inequalities. So we'll set up like both a positive and a negative. But on the negative, we're going to flip the inequality, kind of like what we did up here. So on the negative one, we're going to flip that inequality. All right. And then we still need a graph. So we're going to have to go back to the graphing piece of things. So in this first example here, the absolute value is already isolated, so we don't need to worry about that first step. So our second step is we're going to set up our two inequalities. So we're going to set up both a positive and a negative version of this. So right now it's a positive 24. We're going to keep it as a positive 24. Oops, I don't need the absolute value anymore though. So 2x minus 6 is less than or equal to 24. So this is the regular one. This is the positive one. But then my other equation is going to be the negative one, and on that one I'm going to flip the inequality. So this is where it gets a little bit tricky because inequalities have directions. So we're going to flip the inequality here, and I'll write myself a little note to remind me that I did that. So if you're wondering what just happened there, we flipped it on that negative one. So now we're going to solve these. And just like we did yesterday, we just have two equations to solve. We're going to get kind of two outcomes. We're actually going to put it on the same graph though then. So I'm going to move this 6 over to begin with. We're going to divide by 2. So x is less than or equal to 15 is 1/2 of my answer. That big of a graph. All right, so then we're going to solve the other one. So negative 24 and 6 is going to be a negative 18. Divide by 2. I'm dividing by a positive, so I don't have to flip the inequality again. So I get this answer here. So I get these two parts of my answer. But now I'm going to put that on my number line. And so thinking back to before break about our number lines. Remember, number lines have to go from smallest to largest. So the smallest number is the negative 9. The biggest number is 15. And I don't need to put all the numbers in between, just kind of lay it out that way. Now what kind of circle am I using here? The filled in one, right? Because it has that equal to line. So we're filling in that circle. But now we have to decide, is it going to be like the oars of a boat, or is it going to come together? So x is less than or equal to 15, so less is to the left, but it's greater than negative 9. So this one ends up coming together. So this actually ends up being an and inequality. It's going to be in between these two. It's going to be bigger than negative 9, but less than 15, and obviously can equal that. All right, we're going to do one more before we take a break. Real quick, if you want to look ahead at all, I do need to change this last problem. It should be a negative 7 instead of a positive 7 up here. So I might just alter that right away before we get too far ahead, in case some of you guys work ahead of me. So setting up our two equations. So the first one's exactly the way you see it. Don't change anything about it. The second one, we don't change the left side, but we're going to flip and change the 9. So we're going to flip the inequality and change it to a negative. Oops. So we're flipping that inequality there. And then we're going to solve each of these, and then we have to determine if it's kind of an and or an or inequality when you get done here. I got 4 and -2 is kind of my two boundaries there. And again, we go smallest to largest, so small is over here, larger is over here. But this time, they're open circles, because they don't have that equal to line, so that means they're not included. And then, yeah, so I see Ian, it's like pointing his arrows out here. So y is greater than 4, so we're going bigger than 4, but less than -2. So this one happens to be an or inequality. It can only be one or the other. It can't do both things. So we wanted to kind of write that here, that it's an or inequality. Okay? All right, we're going to pause for a bit here. What's that?